Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Shridevi Classes YouTube channel where we inculcate interest and confidence in science and technology subjects. Today in our Polytechnic Physics playlist, we'll understand emerging nanoscience or nanotechnology introductory subject, and we'll discuss importance or significance of nanotechnology and understand both top to down and bottom to up fabrication or manufacturing of nanomaterial, and we'll discuss application of nanomaterial in electronics and computing, medicine and healthcare, energy and environment, materials and manufacturing, optics and photonics, environment sensing and pollution control, aerospace and defense, consumer goods, agriculture and food industry. Let's start study of nanoscience and nanotechnology. Nanoscience or nanotechnology are interdisciplinary fields. They are convergence of physics, chemistry, material science, engineering and biology. Nanoscience and nanotechnology explores and manipulates matter at atomic or molecular level, and properties and behavior of material at such nanoscale are significantly different from those at normal routine larger scales. Nanoscience is the study and manipulation of phenomena and property or behavior of material at small nano, atomic, molecular or macromolecular scales, whereas nanotechnology on the other hand focus on design, characterization, production, control and application of physical devices, systems by controlling shape and size of material at nanometer scale. So science is study of phenomena and technology is application of those phenomena and unique typical behavior and properties. Nanoscale refer to dimension of material and structure at nanometer scale, that is 10 to the power minus 9 meter, and typically they range from 10 to 100 nanometer, like size of antibodies or virus, which is less than bacteria or cancer cell but more than water or glucose molecule. Now at this small scale, nanomaterial exhibit unique properties and behavior. This study of nanoscience is driven by quantum phenomena, and it open up new possibilities and new scientific opportunities for development of material and devices with enhanced property and very unique functionalities. For example, the bulk presence of silver is non-toxic, but silver nanoparticles have capabilities to kill viruses upon contact. Now the properties such as electrical conductivity, color, mechanical strength and weight will change when material are at nanoscales. Let us understand why material exhibit unique properties or different characteristics at nanoscale. Now these difference in property of nanomaterial arise from increased surface to volume ratio. Smaller size got higher surface to volume ratio. Now there exist quantum effects at small nano size particles, and there are some size dependent phenomena which makes the property of nanomaterial very unique and different. Nanoscience involve study of material which exhibit remarkable properties, functionalities and phenomena due to their small nano-sized dimensions. And here are some example of nano size. Our fingernails are growing at a rate of approximately 1 nanometer per second, and with a significant duration of few days you can see the change in this dimension arising from 1 nanometer per second rate. A DNA molecule has a width of about 1 to 2 nanometer, so you can assess the nanometer scale of measurement. In modern latest generation Pentium Core Duo processor of microcontroller, the transistor which are used got a size of approximately 45 nanometers. The fabrication of nanomaterial or manufacturing of nanomaterial can be categorized into two approach. In one, top to downs manufacturing, the bulk material is fragmented and nanoscale structure are obtained, whereas in bottom up manufacturing, individual atoms are grouped together as assembly of cluster, and these clusters when assembled will form nanoscale structures. So there are two, top to down and second bottom to up manufacturing modes of nanomaterials. In top down approach, the manufacturing of nanomaterial starts with a larger material and it uses chemical or physical processes to break the material down into nanoscale element. Now this method of top down approach is derived from fabrication techniques which we people are using in semiconductor industries. One such technology is photolithography. In this photolithographic method, we selectively remove layers of material from a precursor material using light or electron beam, and electron beam develop material for a particular fabrication, and etching, evaporation and lift of material can produce a surface DNA, and linker DNA approach can ultimately generate nanomaterial. This approach requires significant energy and a large amount of wastage of material, and it is also relatively slow and quite challenging to produce, replicate or nanomaterial in large scales. In contrast, the bottom-up approach starts with individual molecules or compounds which are assembled together into nanoscale material using some combination of chemical and physical processes. Through these tool of chemical synthesis, bottom-up manufacturing can successfully produce quantum dots, plasmonically active particles, carbon nanotubes, metallic nanowires, and some multifunctional particles. The individual molecules are ionized by energy, and these ions form radicals and electrons, and condensation and formation of clusters ultimately synthesize nanoparticles in terms of fluorines or graphene nanosheets. This bottom-up nanofabrication is relatively inexpensive, and if we want to produce similar type of nanomaterial in large volume with a good production scale, then this fabrication is quite straightforward, economic and popular. This new field of nanotechnology has gained significant attention and is experiencing a rapid growth due to its immense potential for technological advancement and innovation. The application of nanotechnology span across various sectors including electronics, medicine, healthcare, energy, environment, material science, agriculture, spacecraft or defense. We'll study application of nanotechnology in various fields one by one. Nanotechnology has revolutionized the electronic industry. It has enabled the development of smaller, faster and more efficient electronic component. Nano-size transistor, memory devices and sensors have led to the miniaturization of electronic devices and circuit that results in advancement in computing powers, enlargement of data storage and fast and efficient telecommunication. Nanotechnology also has revolutionized healthcare and medical services. It has enabled targeted drug delivery systems, improved medical imaging, highly sensitive diagnostic, and the most important, regenerative medicines. Nanoparticles and nano devices are used for precise and targeted drug delivery systems that enhance treatment efficiency and minimize any sort of side effects. Nano biosensors and nano devices enable early disease detection and accurate diagnosis. Nanomaterial also play a role in tissue engineering for regenerative medicines. In energy and environment sector, nanotechnology play a crucial role in development of renewable energy sources and remediation of environment. Nanotechnology is doing significant work. Nanomaterials are used in the development of more sensitive solar cells. They are also used in efficient energy storage devices and catalyst for clean solar energy production. For environment applications, nanotechnology offers solution for water purification, pollution remediation and environmental monitoring. Nanotechnology has transformed the field of material science and modern manufacturing. These nanomaterial possesses exceptional properties such as very high strength, very good scratch resistance, corrosion resistance, and improved chemical reactivity and self-cleaning capabilities. Carbon nanotubes, graphene sheets, and nanoparticles are used in the production of lightweight and high performance, high strength materials. They are also used for scratch proof coatings or special designed composites. These materials find their application in aerospace industries, automotive industries, and they are also used in construction industries. So quantum dots, fullerene, nanorods of metal or ceramics, or nanotubes of carbon or metals, or sheets of carbon coated nanoplates or graphene sheets are used in different applications. Nanotechnology also has revolutionized optics and photonics. Nano-optic component in the form of very thin substrate can manipulate light at nano dimensions. Nanophotonic devices such as nanoscale lasers, waveguides, nanosensors, and plasmonic structures have application in telecommunication, data storage, and optical computing. Nanomaterial like quantum dots can precisely control light emission and absorption, leading to advancement in display devices, imaging, and even in communication. Nanotechnology plays a vital role in environmental sensing and monitoring. Nanoprobes can sense gases, they can have antibacterial activity. Nanoporous sorbents are used in several environmental applications. And nanotechnology also have critical biological sensors. These nanosensors can detect, analyze several type of pollutants, toxin, and contamination in both air and water, that too in real time. These nanosensor devices offer a very high sensitivity, selectivity, and a very fast response time that enable efficient environmental monitoring and control in real time conditions. These nanotechnology based sensors are used in agriculture, food safety, and water quality monitoring. Nanotechnology also has a significant implication for aerospace and defense. Lightweight carbon nanotube, airframes, or other nanomaterial are used to develop stronger and more durable components for aircraft and spacecraft. Nanotechnology has enhanced the performance of sensors, electronic circuits, and they also provide very good protective coatings which is used in defense systems. Nanotechnology has influenced various consumer products ranging from cosmetics, clothing to electronics or sports equipment. Nano coatings provide strain resistance, scratch resistance, and improved durability to household appliances and devices. Nanoparticle of titanium dioxide effectively block ultraviolet radiation, and nanoparticle in sunscreen offer enhanced UV protection. Nanofiber in clothing provide moisture and wicking resistance property, and they also have antimicrobial properties. Nanotechnology also has application in agriculture and food industry. They are used in crop improvement, pest management, and food packaging. Nanotechnology means can increase productivity of crop, they can improve quality of soil, they stimulate desirable plant control, and they are also used in smart monitoring systems. Nanoscale delivery system enhance efficiency of fertilizer and pesticides that reduce adverse environmental impact of fertilizer and pesticides. Nanomaterial in food packaging improve shelf life of food components, prevent their spoilage, and ensure food security and safety. In conclusion, we can say nanoscience and nanotechnology present an exciting opportunity for new scientific exploration, technological advancements, and innovation results across various fields. Their contribution ranging from food packaging and processing to cancer therapy and regenerative medicine nanotechnology has the potential to offer a wide variety of proficiencies which can be utilized in a reasonable and thoughtful manner to drive positive changes in our industries, healthcare, and many other areas of our mankind. We hope this learning video has given us critical introductory idea of nanoscience and nanotechnology. Now you are aware of nanofabrication of either top down or bottom up approach, and you get an idea of application of nanotechnology in various fields. Our other learning video of the same playlist are equally useful. You can use them in your studies or share them with your friends. If you need dedicated study notes from this channel, do join our membership. Happy learning. Have nice time. Thank you very much.